Hello, welcome to another class for GATE 2027. This is a GATE problem which appeared in 2021. It's a numerical aptitude type problem carrying 2 marks. For a vector field B equals rho cos square phi a rho plus z squared sin square phi a phi in a cylindrical coordinate system rho phi z with unit vectors a rho, a phi and a z. The net flux of D leaving the closed surface of the cylinder rho equals 3, 0 less than or equal to z less than or equal to 2. Rounded off to 2 decimal places is dash. Now this problem can be done in 2 ways. Let me do the straightforward way first, and then in the next video I'll show you how to do it using divergence theorem. We are given D equal to rho cos squared phi a rho plus z squared sin squared phi a phi. Now we know that the flux of D leaving the closed surface is given by closed integral of D dot x. And here it's a cylindrical surface, so the flux comes out of in a radial fashion or in this direction. There are only 2 directions in which the flux can come out. So in this direction, the vector direction is a rho, and ds can be written as it is this is rho d phi and this is dz rho d phi dz a rho. And there is no z component, so there is no flux coming out in the direction of az. So it becomes very simple. It's a simple integration along phi and z. Z changing from 0 to 2 and phi changing from 0 to 2 pi. And you have only the rho component, so the phi component is not taken, so it becomes a simple integral rho cos squared phi rho d phi dz. And we know that cos squared, and there is no integration with respect to rho, so I can take rho squared outside, and there is no function of z inside the integral, so I can integrate from dz from 0 to 2. That gives me 2, and I integrate cos squared phi from 0 to 2 pi. Actually, cos squared phi can be written as 0 to 2 pi 1 plus cos 2 phi by 2 d phi. Again, if you integrate cos 2 phi, you get sin 2 phi, and if you put the limits phi equal to 2 pi and 0, both the cases sin 2 phi is 0. So that component will vanish. So we'll have only d5 by 2 integrate from 0 to 2 pi. If you integrate d5 by 2, you get 5 by 2. From 0 to 2 pi, if you integrate, you will get 2 pi by 2, that is pi. So effectively, this becomes 2 pi rho squared is the flux that comes out of the surface, and we know that rho is 3, so it is 2 pi and 3 squared, that is 18 pi, which is 18 into 3.14. So if I calculate it, 18 into 3.14 is 56.5. So this is equal to 56.5. 55 is the answer to this problem. Thank you. God bless you.